Hello friends, we have already discussed specific heat capacity and molar specific heat capacity. So today we will discuss two variations of specific heat capacity. One is specific heat capacity at constant volume CV and another is specific heat capacity at constant pressure Cp. So, by now you must have understood what is specific heat capacity, but I'm repeating again that specific heat capacity is the amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius. So we have heat, some amount of heat which is required to raise the temperature of 1 gram of substance through 1 degree Celsius. So, whenever we add heat to any substance, its temperature increases. We all know that. But now this increase in temperature can be done under two conditions. First, by keeping volume constant, and second, by keeping pressure constant. Because whenever we provide heat to anything, its temperature would increase. This is for sure. But we can manage or we can optimize the whole condition by heating the substance under two different conditions. So, as we all know that the major thermodynamic variables are P, V and T, pressure, volume and temperature. So now, whenever heat is added to anything, the main thing which is always affected is the temperature, because whenever heat will be added to any substance, to any gas, its temperature would rise. So Q added to gas implies rise in temperature. So this is what will definitely happen. This kind of thing would always happen. But now these two variables, we can play with these two variables. Now, will this heat affect these two variables? So now, that's why we have two different conditions. That let's see what happens when gas is heated under two different conditions. So, one thing is for sure that whenever we'll heat the gas, its temperature would increase. But now let's see what happens when we keep volume constant and what happens when we keep pressure constant. So first we come up with specific heat capacity at constant volume. So now what is the definition of specific heat capacity at constant volume? So CV, amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius at constant volume. So, specific heat capacity at constant volume, CV, is defined as amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius at constant volume. This is very easy. This whole up to here, we know this definition is for specific heat capacity, small c. So all we have to do is, what if everything happens at constant volume, this becomes specific heat capacity at constant volume. So now let's study what is specific heat capacity at constant pressure. So again, specific heat capacity at constant pressure is defined as same amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius at constant pressure. So now again, up to here we have what we know is specific heat capacity, and if everything happens at constant pressure, that becomes specific heat capacity at constant pressure. So there is no difference, no major difference I would say between the two. The only is that the whole process for specific heat capacity in case of CV happens at constant V, and the whole process of specific heat capacity in case of CP happens at constant P. So amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius at constant volume is specific heat capacity at constant volume. It is known as specific heat capacity at constant volume. An amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius at constant pressure is known as CP, specific heat capacity at constant pressure. Now friends, there is one more thing. These two specific heat capacities, they are not equal. Out of these two, one is greater than the other. Now who is greater than whom, we have to check. So now let's see what actually happens at CP and CV. One more formula that I would like to put forward here is Charles' law, which states that for any given gas at constant pressure, the volume is proportional to the temperature. So the volume of the gas will expand in proportion to the rise in temperature. This is our Charles' law. So this law applies whenever we have constant pressure, because in thermodynamics we deal with P, V, T. These are our major thermodynamic variables, and most of the activities, most of the operations, they occur involving these three variables. So this you have to keep in mind. Now let's see what happens when gas is heated at constant volume. So when gas is heated at constant volume, obviously there will be no change in volume. But as gas is being heated, temperature would increase. And we have also observed that when we heat a particular gas at constant volume, its temperature increases, there is no change in volume, and that's why no change in pressure happens. No change in. Further, I would like to mention here no appreciable or measurable change in pressure happens. So that's why we say that there is no such change in pressure happening under this situation. So when a gas is heated at constant volume, so we would say that specific heat capacity at constant volume is involved. So there will be no change in volume. Temperature will definitely increase because gas is being heated. And we have also observed that there is no appreciable or measurable change in pressure. We have not seen such significant changes in pressure happening. So we don't say that there is any change in pressure. We can't say. We can't make any statement for that. Now let's consider another scenario, which is when a gas is heated at constant pressure. So now when gas is heated at constant pressure, this Charles' law comes into play. We know that at constant pressure, volume is proportional to temperature. So now that same amount of heat, if we say Q is here, and now if we try to use the same Q here, so now this Q is doing two things. It is expanding the volume, plus it is increasing the temperature, and our pressure is constant, so no change in pressure. Here, this Q was doing only one thing. This Q in case of CV was only doing this thing, that is increasing the temperature, because pressure also wasn't changing that much, no significant change, and since everything was happening at constant volume, so no change in volume. So whatever heat was being supplied, the only thing it had to do was to raise the temperature. So that was pretty much easy for the heat to raise the temperature because it has nothing else to do. But when we talk about CP, now here obviously pressure will not change because we are doing everything at constant pressure. But now both volume and temperature are equally independent, and we know that according to Charles' law, for any gas at constant pressure, volume is directly proportional to temperature. So if temperature rises, volume also expands. So now here, if you provide the same amount of heat, it has to do two things. First, some amount of heat will be spent in raising the temperature, and some remaining portion of the heat will be spent in increasing the volume. So now this same heat has to do two tasks here, whereas in case of CV it was doing only one task. So more burden on Q here. So if I would like to mention here that if in case of CV only say 10 joule of heat was raising the temperature by 1 degree Celsius. Now, what do you think? Would that 10 joule of heat would be able to raise the temperature here by 1 degree Celsius? Here, this heat in case of CV was doing only one task, that is to raise the temperature. So, after observation, we got to know that 10 joule of heat was being provided, and that was enough to raise the temperature of the gas through 1 degree Celsius at constant volume. But now when we provided same amount of heat here, would it be able to increase the temperature of gas by 1 degree Celsius? No, because the same amount, 10 joule, maybe 5 joule is getting spent here and only 5 joule is going there. Or could be maybe here we can say that 3 joule is being spent in expanding the volume, and the 7 joule is spent in raising the temperature. And if we know that for the same gas 10 joule is required to raise the temperature by 1 degree Celsius, here also we was providing 10 joule, but now for this temperature only 7 joule is available. So then we need to add some more Q here. Some more heat needs to be applied so that we can actually change the temperature by 1 degree Celsius. I'm explaining again. We are considering the case of same gas so that all the conditions are similar. Same gas. And let's say same amount of heat we are providing. So first case we did was CV, when everything was being done at constant volume. So we know at constant volume there is no appreciable or significant change in pressure. So almost whole quantity of heat is being spent in raising the temperature. And by experiment we got to know that okay, 10 joule was enough to raise the temperature of gas through 1 degree Celsius. Now we took the same gas, but the only change we did was now we did our experiment at constant pressure. So since the experiment at constant volume gave us the result that 10 joule was capable to increase the temperature by 1 degree Celsius. So here also we thought to provide 10 joule of heat. But now we know at constant pressure both volume and temperature are fully independent. Temperature will also change and volume has also the equal independence to change as per Charles' law. So now if we provide here 10 joule, so maybe half of the or some percentage of the heat will be spent in raising the temperature and some portion will be spent in expanding the volume. So if it is any ratio, be it 1:9, 2:8 or 8:2, anything like that, the one thing that is certain is that this 10 joule of heat will not be able to raise the temperature by 1 degree Celsius, because here to T, full 10 joule will never go, because some of the portion will always be captured by volume, or we can say that some of the portion of heat will always be spent in changing the volume. So this T would not receive 10 joule, proper 10 joule heat. So then to raise the temperature by 1 degree Celsius, we have to provide some more heat. Now what we conclude here, that in case of CP, we need more heat. The specific heat capacity needs to be more as compared to that at CV. Thus, we conclude that our CP is greater than CV. That is, to increase the temperature of the gas to the same value in case at constant volume, more heat is to be supplied at constant pressure. To increase the temperature of the gas to the same value which was that obtained at constant volume, more heat is to be supplied at constant pressure. And that's why specific heat capacity at constant pressure is greater than specific heat capacity at constant volume. Thank you.